Hello viewers, welcome to this video. This is Jerry's Tech once again. Okay, in today's video I thought of showing us all how we can automate our systems in case maybe the power company takes power, or maybe there is any power interruption. Our systems, for example, the kettles. I'm using this kettle now as an example. You may also include your cookers, irons, your heating elements, your heaters, your pumping machine, so that whenever there is the power company restores power back, you don't have those systems coming on their own. Because if it's an ordinary switch, a socket switching which you put on and off, if power is interrupted, when it comes back, you have this issue of maybe you are not at home, and those things starts working on their own. Sometimes we tend to go out of our homes and we forget to turn off most of our equipment and appliances. But this system now is a very simple system, because I do this in order to help us all. You can buy very few stuffs and automate your socket so that power won't come on when you are not expecting. So that is the purpose of this video today. I will show you the little wiring here. Is very simple. It's something which that you can do. It's a DIY system. So okay, let me just test this so that you see how exactly it works. You see, for example, this is my kettle. See? Okay, there is power now from the power company, so the power won't come here directly until I engage it. See, kettle now is on. If I want to stop, I stop with this. This is just little switches which I will show you how they work. Really, it's not difficult, it's very simple. So if there is power now, I come here on my own and I turn it on. See, my kettle comes on. Okay, for example, the power company takes their power, it goes off on its own, and they restore the power back. There is no power here in the kettle, as you can see. So the same thing as I said earlier on, you can use it for your fridges or whatever. Again, another benefits with this is that if you are running a portable generator in which you are sure those generators, maybe the generator that you are using is not powerful enough to pick up your freezers, your fridges, your compressors, your electric kettles, your irons, your heating elements and all that. So maybe there's a power outage and you hurry down to get your gen on. Immediately you put on your gen, you have all those loads on the socket already. So it will overload the gen and will put the gen off. It may even damage the gen. So it's better if you use this kind of system. Like myself, if there is power outage, I don't go, because most of my sockets in which I don't want them to come on when there is a power outage or when power is being restored, I don't have to go around putting them off. I just install this contactor and these switches close by. So when there is power, when there is power outage, I don't need to go down. I don't need to go around to be offing things before I start my gen. I just go straight to the gen. Even your inverter system, you can also do this for it in order to protect the life of your inverter system, because with time, if you overload the systems, you damage the inverter. So same thing goes to the portable gen. So you don't need to go around putting off things if you have this system in place, to control your sockets. So that is that. Okay, for now, let me show you the way I wire these stuffs. Is very, very simple, trust me. Okay, I take power out. Now we see This is the power supply. So you can see this is the power supply from the source, the sockets, the power company. So let me start from the most easier one. This is a contactor. The supply is 220 volts. I mean, to the coil, supply to the coil is 220 volts. So depending on the country which you are in, some may be 110 thereabouts. So you check and you know which one to buy. If you want to use a DC control, you can as well use a DC control. But in my own case, since I'm using this AC and I don't want to bring in another external power, so I use the same power from here to power the contactor. So as you can see, the contactor always have a particular unit in which you find A1 and A2. A1 and A2, that is the coil that energizes the contactor. So this switch now is a normally closed switch. It's a normally closed switch. You use it to stop the system. If the contactor is energized already and you want to stop, okay, maybe you want to stop this electric kettle, you can simply press here. So it's normally closed. That means when this switch is idle like this, the two contacts here is has continuity. That means they are joined together, they are looped together if it's normally like this, until when you press it, then it will open up. This contact will open up. So that is that. So I use this to stop, because now, as you can see, the power from here, the power from this neutral line gets straight through this switch and goes into the A2 part of the coil. See, it goes straight until when I press it like this, then that means that power has been interrupted. The circuit has been interrupted. So on the live side, see, on the live side, this is a loop. I put one like this. This switch is normally open. It's normally open. That means when it is like this, when you don't press it, this loop is open. There is no continuity within this loop. So until when you press it, it bridges this loop. So you have continuity when you press it. So now I put this line, one of the lines, on the A1. I put it on the A1. Then I take one of the lines to the main power line. See, I join it to the main power line for the lifeline that's coming from the mains. So on a normal case, a normal scenario, since power is coming through here into this switch, being that it is normally open, it will not get to the coil in order to energize the coil. Remember, the neutral side is always on, as the switch is always is looped already. Until when you press it, that is when you break the circuit. But in this case, this one is open, so it's only when you press it, when I press it, is when I am able to energize this coil. So if I press it and leave it, that means the coil will energize, and also when I leave it, it will de-energize, as it will disengage the contactor. So what I do is, since I loop this line from this A2, or sorry, from this A1, this live side, I loop it also down to this supply, or to this line going to the kettle. As from here down, then I loop it back to the A1. Why I'm doing so is that, so that when I press this and it energizes this contactor, remember, power passes from here now to this kettle. After you press here, power passes from here straight to this kettle. So that power that passes, this one, this very line now, takes the power back to A1. So it will keep that contactor energized, since there is constant power passing here. So if I press it and it engages, when the contactor engages, it sends, it allows this very main supply to go down, and it comes back again. So by so doing, even if I release this, the contactor won't go off, because power is continually going there. Okay, if I want to stop it, So I press it, since this is a direct loop to the A2. So if I want to stop it, I press here to open the circuit. When I open the circuit, in order to close back this circuit, as in order to energize this contactor, I have to repeat the process again by pressing this. So you see where the trick is. So that is why when power comes, it will stand by until you energize here before the power comes. So this system is very good. It has helped me for so many years. The way I use it with my systems, it has helped me keeps my stuffs, my appliances very safe, keeps my inverter healthy, and save my generator in a very sound mode, because they don't carry load in which I am not ready for. So if I need them to carry a particular load, then that means I'm prepared for it. So I energize it myself. I don't okay, for example, I'll show you. Let me show you a particular system that I'm using with. Okay, viewers, for example, I have this electric cooker. I have my oven. So I have this installed. So if I want to energize this switch now, okay, already it's energized. Okay, and if power comes back, it doesn't come on. So in this case, since I'm the one using it, I don't require a switch. So what I do, I just press it in and it engages and stays there. But if power goes off, see, comes up. So if I plug this, maybe my cooker or whatever here, and the power company takes their power, so I don't need to worry to come here, because I know that when power is restored, my systems are safe. Because the power will be on standby until when I energize it. Okay, thank you for watching this video, and I hope I was able to impact a little knowledge. Maybe you learned one thing. Please like, share, and subscribe. Okay, thumbs up. Okay, have a nice day. Bye.